So example number 3, determine the slope at the right support and deflection at the free end. So what we're going to do here is try to draw the deflection. That. And then we will be placing letters to every point. A, B, C. And this is D and this is E. Then let's solve for this resultant. This is 15 times 2, 30 kilonewtons. And I'll have here BV or RB. So RB and RE. So let's solve for the reaction. Summation of moment about point E equal to 0. You will have RB times 5 meters and then equal to 30 times, this is 1 plus 2 plus 2, so that's 5. And then plus 50 times 2. So RB is, that's 30 times 5 plus 50 times 2 divided by 5. So this is 50. Next is summation of forces vertical equal to 0. You will have RB plus RE equal to 30 and 50. Then you will have RE equal to 80 minus RB nga 50. So RE is 30 kilonewtons. Next, we're going to draw the moment by parts, but before that, we're going to drop down a line and let's copy this. Let's move it here and copy, then paste. For B, it's found here. And then for C, it's found here. Let's just move this down. And then for this portion, D, this one. And then for this. And then do not forget to write a 0 moment line. Okay. So, a simple tip, whenever pangitaan gali ka o deflection, whenever na ay overhanging beam, always rotate at the interior support. So always rotate. Ngano di ay? Because it's going to separate your load diagram later on. Kay interior man na, mahimo na siyang internal hinge later on. So better nga diha mo siya i-rotate. So there. We're going to proceed with the moment by parts. Starting with this. So this will give you 15, right? So 15 times 1, it's 15 downward. So may tabo kay 15 times 1/2 of 1. So negative there. So this is 7.5. This is second degree. Next, this one. Can you see ang portion? You need this. So the resultant is 15 also. So same rapod na siya illustration diha. And the value here is, just transfer this. And then this is 7.5. This is 2 degrees. Next, the RE. So RE times 5. So RE is 30. 30 times 5, 150. So it is 150 upward. So can we transfer this? That. Okay, and then there. And then let's proceed with the RE. RE. It's 150. So this is 30 times 5. So this is 150. And then this is at first degree. Can I just move this down? And then, oops, nabilin si 5 there. Okay, and then the other one is 50 times 30 downward. So 50 times 3, it's still 150. So this is 150. And this is at first degree. Okay. What we're going to do now is draw the moment by parts. Draw the conjugate beam. So let's draw the conjugate beam. So for the conjugate beam, let's copy the beam length. The beam length is 6 meters. So I'll just draw same beam length. Uy, nawa. So I'm drawing here kay para at least closer to reality ang ato ang beam. And then put it here. Okay. And then we're going to evaluate the supports. Let's write the letters. So this is for A, this is for B, this is for C, this is for D, and this is for E. But this time, they are now A prime, B prime, C prime, D prime, E prime. And evaluate the support at point at point E, the support is hinge. So we're going to redraw the same hinge at point E. Right? And then at point A, it's a free end. So it will become a fixed end here. So i-move sa nina to. And it will become a fixed end. So fixed end. Next, at point B, the support is an interior roller. So in the end, it will become an internal pin. There. So put back the loads. So I'll transfer this load here. I'll just get this here, and this one, and then I'll move it downward little bit. Okay, and the value here is 150. Copy 150 and 1. So this is this is 150, then 1 degree. Okay, and then mo na iyahang direction kay positive moment man siya. So irisan lang sa ako. Okay, next is I'll put back this one. So let's copy that and place it here. Then of course it has a vertical line. We're actually drawing again the figure, and then since this is a negative moment, by the way, the value here is 150 and it is at first degree, so negative man siya, so downward ang iyahang direction. The same ani. Okay, next these loads, kani sila nga load. I'll just copy this, load, copy, and then paste it here. So again, na kay load diha downward because this is a negative. No. Also, do not forget that you still have this load. Copy and paste it. Of course, you have to place direction downward. So what's next is get the resultant. So I'll have here R1. I'll call this R2. Then we have here R3. So ito lang isibo gamay. This is 7.5, and then this one there for R3, and then we have this ataybalhin kadiyot here, and then we have the R4. So let's solve for the values of R1 hantod sa R4. R1 is napadaytay distances. Then copy. And this is for there. So we have this distance. So the distances are 1 meter, 1 meter, 2 meters, and 2 meters. And somehow, ako nang delete, and then this one. So kani siya kay wala na delete. Okay. So here, let's just move it up a little bit closer upward para makita na to ang distances. So R1 is 1/2 of 150 times 5 times 5. So that's 1/2 of 150 times 5. It's 375. The unit here is kilonewtons square meter over EI. And then R2, it's 1/2 of 150 times 3. So 150 times 3 times 1/2, it's 225. And then for R3, it is base nga 1 times 7.5 over 2 plus 1, which is 3. So that's 7.5 over 30. So this is 2.5. And the same with R4. Now 1 times base times 7.5 over 2 plus 1. And this is 2.5. Okay, so our beam now is no longer a simple beam or a determinate beam, but rather it's a kanang compound determinate beam. So what we're going to do, since naman tay internal pin, no, by the way, basig nakalimot mo, this is an internal hinge or pin. So para maka-solve this reaction, what we are going to do is cut the beam, diba? So let's just have the assumption of our kanang direction of the reaction. So I'll place here MA prime, and then I'll place downward RA prime, and then I'll place here a downward of RE prime. So what we're going to do is cut through the beam. So we're going to cut this beam portion, and then we're going to consider the right side, no, para ma-solve siya. So if that's the case, matangtang siya from the system and mugawas ang reaction sa internal pin. So let's copy that and paste it here. And then we're going to remove some nga walay labot. This one here. So we're basically cutting the portion at point B. So there, ato siyang i-cut. So we're cutting that portion. Okay, so kay nag-cut man ta diha, na gawas nga reaction, internal reaction. So although na horizontal force diha, anyway, ibutang na lang nako. You have the BH prime, and then I'll just place any direction. Anyway, this is just 0. And then I'll place downward direction for BV prime. So this BV prime is really important para ma-connect nato siya sa pikas. Okay, so from here, we can now solve the value of our reactions, diba? By having summation of moment about point E, no? Mag-summation moment ta about point E prime para ma-solve ang BV prime, diba? And also, solve sa nato si BV prime and RE prime, diba? So, continue. Summation of moment about point E prime equal to 0. You will have clockwise positive, counterclockwise negative. So negative BV prime, counterclockwise man siya with a moment arm of 5, and then minus R3 times 2 plus 1 over 2 plus 2 of 1 plus 4, and then minus R2 times 2/3 of 3 plus 2, and then I'll just move here, and then plus R1 times 2/3 of 5 equal to 0. So basically, we're going to move this to the other side, transpose that to the other side. It will become BV prime times 5 equal to negative R3. So R3 is 2.5 times, that's 2 plus 1, 3. 3 over 4 plus 4. So it's 4.75. And then minus R2. R2 is 225. 225 times 2 times 3, 6 divided by 3, that's 2, then plus 2, so times 4, then plus R1. R1 is 375, so that's 375 times 10 over 3. So BV prime is equal to, so that's negative 2.5 times 4.75 minus 225 times 4 plus 375 times 10 over 3, and then divided by 5. The answer is, that's 67.625 kilonewtons square meter over EI. And then for RE prime, just do the summation of forces vertical equal to 0. You will have negative RE prime, then minus BV prime, then minus R2, then plus R1 equal to 0. Oh, napay R3. Do not forget. Then minus R3 equal to 0. Then transpose this to the other side, it will become positive RE prime. And you will have negative 67.625 BV prime minus 225, then plus 375 then minus 2.5 for R3. Okay, so RE prime is negative 67.625 minus 225 plus 375 minus 2.5 divided by 5. Balik ko na ko. Not divided by 5. So that's negative 67.625 minus 225 plus 375 minus 2.5. Here. The answer is 79.875 kilonewtons square meter over EI. And then i-rearrange lang nato. Okay, so you have the RE prime already. Okay, our objective is to solve for BV prime because that is our value to be transmitted to the other side of the beam. So this is the other side of the beam, and what we're going to do here is to cut the beam here to the right side. So let's cut it, this portion, and copy. So ika-cut, I'll paste it here, and then I'll delete some mawalay gamit. This one and this together with this and this one and that. Oh, no, what? See, this is R4. Yes, this is R4. And then wala na siya labot. Then we're going to cut here. Cut ni siya. So mawa na siya. And also this. So this is our point B prime. And in this B prime, there is a BV prime. So sa may direction, ang direction na to diha is downward. So in this free body diagram, it will become upward. So the value here is 67.625. And then the value of R4 is 2.5. And the length of this beam is 1 meter. In this case, we're tasked to solve for the deflection at A. Meaning to say, in the conjugate beam, we're going to solve for the moment at A. Okay, again, MA prime in the conjugate is equal to the deflection at A for the real beam. So summation of moment at the point A prime, because we don't have this value yet. So it's better to take moments there and equal to 0. Clockwise positive, counterclockwise negative. So you have MA prime, counterclockwise negative, and then plus 2.5. Moment arm, it's going to be 2 plus 1 over 2 plus 2 of 1. That's the moment arm. And then minus BV prime times 1 equal to 0. Transposing this to the other side, it will become positive. So MA prime equal to 2.5 times 3 over 4 minus 67.625 times 1. MA prime is 2.5 times 3 over 4 minus 67.625 times 1. The value is negative. It says here negative. So negative 65.75 kilonewtons cubic meter over EI. It says here na negative because our direction na counter is wrong. So it should be clockwise. So whenever naatay beam, and then we have here the BV, and we have the moment nga clockwise, MA prime. So this action of MA prime with respect to this beam, it will bend upward. So in this case, this moment is positive moment. So this moment creates a positive moment. So kung positive moment sa actual beam, then therefore, conjugate beam rather, kung positive moment sa conjugate beam, ang pasabot ana in the deflection for the actual beam at point A, you copy the value 65.75 kilonewtons cubic meter over EI, and this one, since that is positive moment in the conjugate, so for the actual beam it's going to be deflection upward. So there, this is our deflection at the free end. Okay, next question is solve for the slope at the right support. So solving the right support slope, all we have to do is cut this portion and consider that. So I'll cut that portion of the beam, and here, solving for the slope at the right support. Slope at the right support. Paste here. Erase this portion lang. This one and this, and also that one. Then I'll leave a length para sa ato ang slope, and then I'll erase this everything. Okay, and then parakan lang ako siya. Alright, so at that portion we have this shear at E prime, and this is downward, so I'll place upward. And again, VE prime in the conjugate beam is equal to the slope at E for the actual beam. And then summation of forces vertical equal to 0. So you have the VE prime VE prime upward equal to the RE prime, and the VE prime is RE 79.875 kilonewtons square meter over EI, and the rotation is clockwise. So if that is clockwise, it says here clockwise motion, then therefore the slope at E is negative 79.875. So that's the conclusion. And then this is the final answer. The slope at the right support. So, how about bonus question lang? How about maingon ang problem nga solve for the deflection at the midspan? So, midspan ana niya. So, here. What you're going to do is locate midspan. Since the span is 5, then somehow naadiri ang 2.5. No? So we're going to cut through this portion and consider the right side since it's simpler. No? So just in case lang. So pasulbuntaan na. So I'll just copy this. Okay, so what if deflection at midspan is asked? So ang buhaton is paste this portion and then erase-on lang nako ang walay gamit. So kani this one and then here and here, also here, and then let's remove that, and then here we don't have the value of this kay it's just a portion sa imuhang triangle of a bigger triangle. So what are we going to do? And also for this smaller triangle we don't have this value, so let's call this one as y1 and I'll call this as y2. Again, we're cutting it at 2.5 meters. And this distance here pila na siya. So if this is asa na to dapita, if this is the portion of 2.5 meters and you have 3 here, so therefore the length is 0.5, right? Sakto, 0.5. Yes, because this length is 2.5 and this length here is 3 meters, therefore this length is 0.5. No, so that's 0.5. Okay, that's all for the values of our y1 and y2. But how? So what we're going to do is copy this portion here na lang. I'll just copy this for this is what we are going to do. Ato siyang ratio and proportion. So I'll just erase this. Also this one, and then I'll have here. So I can now get the proportion, diba? Because this length here is 5 meters. So y2 over 2.5 is equal to 150 over 5. So y2 is 75 kilonewtons square meter over EI. How about for this y1? So copy, and I'm just going to copy this portion. Copy that. And then I'll delete some. Wala gamit. This one. And then this one. And that. Okay, so I'll just move it here. And by ratio and proportion, by the way, the distance here is, pila may distance ana niya? It's 3 meters. So this is 3 meters. So ratio and proportion, you have y1 over 0.5 equal to 150 over 3. So y1 is 0.5 of 150 divided by 3. So it's equal to 25. And the unit is kilonewtons square meter over EI. Okay, so with that, since na naman daaning ang mga illustration, all we are going to do is get the new resultant. So I'll have here the new resultant. I'll call this as R5 and here as R6. So that's all. R5 equal to 1/2 of y2 times 2.5. So that's 1/2 of 75 times 2.5. So that's 0.5 times 75 times 2.5. It's 93.75. And then for R6, it's going to be 1/2 of y1 times 0.5. So it's 1/2 of 25 times 0.5. That is equal to. So that's 25 times 1/2 times 0.5. It's 6.25. Okay, so since we're asked to solve for the deflection at the midspan, then deflection for the actual beam is equal to the moment in the conjugate beam. So I'll just place here counterclockwise m prime, no, m prime lang, or mo prime. I'll just call this point here as point O, no, O prime, and then here as, in this deflection at the middle, I'll call this point as O. Alright, so with that, we can now proceed in doing the summation of moment at point O prime equal to 0, clockwise positive, counterclockwise negative. You have negative MO prime, and then plus R6 times 1/3 of 1/3 of 0.5, and then plus RE prime times 2.5, and then minus R5 times 1/3 rather, 1/3 of 2.5 equal to 0. So transposing MO prime to the other side, it will become positive MO prime, and that is equal to R6. R6 is 6.25 times 1/6, then plus RE. What is the value of our RE? It's 79.875. So 79.875 times 2.5 minus R5, 93.75 times 2.5 over 3. Pila na siya? That's 5/6. So MO prime is 6.25 times 1/6 plus 79.875 times 2.5 minus 93.75 times 5/6. The value here is 122.604. 122.604 kilonewtons cubic meter over EI. It says here nga positive because we arrive a certain direction nga sakto, nga counterclockwise. So kung natin counterclockwise with that beam, ang effect ana niya, this is the beam and this is the loading RE prime, and this is the counterclockwise MO prime. So it will create a negative moment. So if that is a negative moment, ambot pasabot ana niya that a deflection at point O in the real beam is equal to 122.604 kilonewtons cubic meter over EI, but it is downward. Kay negative bending moment man ang sa conjugate beam. So this is our final answer, and this is midspan deflection. So that is our problem number 3.